Welcome to this explainer. Today, we're diving into what is honestly the ultimate mystery of human exceptionalism. I mean, have you ever stopped and really wondered how we, out of the millions of species on Earth, ended up as the ultimate innovating species? We are going to decode the biological and cognitive secrets behind human imagination and figure out exactly how we built the modern world.
Take a quick look at the technology around you. The device you're watching this on right now, the architecture outside your window, the medical science that keeps us alive. Now ask yourself a fairly profound question. Why are humans, who are biologically so incredibly similar to other primates, the only creatures building complex computers, writing laws, and launching rockets? Lots of animals are perfectly adapted to their environments, sure, but we're the only ones who actively reshape our environment using high-level, abstract ideas.
For thousands of years after the dawn of basic agriculture and early tools, human innovation moved at an absolute crawl, just slow and steady. But then, as we hit the modern era, going from the steam engine to the automobile, mapping the human genome, landing on the moon, our progress just explodes. It's this massive vertical spike on an exponential curve, a complete explosion in both population and technological mastery. We didn't just keep adapting, we literally learned to invent on a massive, unprecedented scale. So, how did we pull this off? To really understand this explosive growth, we can't just look at the tools we made. We have to look inward. Think of the human brain as a biological supercomputer. At some crucial point in our evolutionary history, this computer got a major, unprecedented hardware upgrade. But it wasn't just the hardware. It was combined with the ultimate networking software. And it's the fusion of those two exact elements that completely unlocked our capacity to innovate. Our brain is this beautifully complex organ. For decades, neuroscience really just focused on how it processes sensory data from the outside world, managing our basic survival and motor functions. But the real magic? That happens when we look at how this physical hardware manages our internal world. It runs our highest levels of abstract imagination, giving us the power to visualize things that literally do not exist yet. Enter the Precuneus. Historically and linguistically, this region carries some profound meanings. For example, it's sometimes referred to as al-talal in Arabic, which beautifully echoes this idea of looking at the remains or the very foundations of thought. Throughout our evolution, this specific area underwent a massive expansion. The Precuneus is essentially the physical engine for our internal thought. It's the foundation that lets you hold high-level abstract concepts right in your mind's eye. Without this upgraded hardware, we simply wouldn't have the processing power to imagine a new tool, conceptualize a mathematical vector, or invent a justice system. Here is the wild part. You probably think your brain is working its absolute hardest when you're furiously typing an email or solving a tough puzzle. Actually, scratch that. The default mode network, which the Precuneus is a massive part of, kicks into high gear when you're just staring out a window or lying in a hammock. During those quiet moments of rest, this network is busy simulating future scenarios and mashing up abstract concepts. So hey, next time someone catches you daydreaming, just tell them your biological hardware is doing the vital work of creative innovation. But hold on, there's a huge catch here. Even the absolute most powerful biological hardware is severely limited if it's operating totally offline. Imagine an early human whose Precuneus fires up with the perfect blueprint for a revolutionary new hunting trap. If they have zero way to communicate that abstract idea to the rest of their tribe, well, the invention dies the second they do. The greatest hardware in the world is completely useless without a network to share the data. Now, there is a massive gulf between animal communication and human language. Animals absolutely communicate, right? Bees do their waggle dance for pollen, monkeys sound alarms for predators. But that communication is largely tied to immediate, localized needs. Human language, on the other hand, is a completely different operating system. It allows for infinite combinations of symbols to express high-level abstract ideas. It literally allows for mental time travel. We can discuss what happened a century ago or debate what we're going to build 10 years from now. And that software lives right here, in specialized regions of the brain like Broca's and Wernicke's areas. These centers are the exact networking protocol our minds needed. They made it possible for the incredible abstract imaginations generated by one person's Precuneus to be perfectly encoded and then transmitted directly into the brain of someone else. Oscar Wilde actually hit the nail on the head when he said, "Language is the parent and not the child of thought." It's a philosophical insight, but it beautifully captures exactly what modern neuroscience is discovering. We tend to think of language just as a tool for outputting thoughts we've already formed, but it goes way deeper than that. Language provides the actual architecture that allows complex abstract thought to exist in the first place.
I want you to think of language as mental scaffolding. Just like physical scaffolding lets construction workers build a skyscraper way higher than they could ever reach on their own, linguistic scaffolding allows our biological hardware to reach so much deeper into abstract realms. It helps us build incredibly complex mental structures, conceptualize algorithms, and organize whole societies in ways that just wouldn't be possible without the words to anchor those concepts.
Which brings us to this brilliant realization by the philosopher Ludwig Wittgenstein: the limits of my language mean the limits of my world. Words for abstract concepts aren't just convenient labels. They are vital cognitive tools. Every time we learn language, we're actively expanding the boundaries of what our individual minds can even conceptualize. The more robust our language, the more incredibly powerful our capacity for abstract imagination becomes. Okay, let's put the whole puzzle together. How does this ultimate innovation engine actually run? Step 1. The expanded hardware of the Precuneus, our Talal, generates the abstract idea. Step 2. Language steps in and encodes that idea into a structured format. Step 3. Communication transmits that encoded idea from one brain to the next. And finally, Step 4. The real game changer: intergenerational stacking. Ideas don't just spread, they pool together into this massive, shared reservoir of human knowledge. By networking our brains together through language, we're basically creating a generational supercomputer. This is the whole shebang. This is what truly separates us from every other species on the planet. It lets us completely bypass the limits of a single human lifespan. Thanks to high-fidelity knowledge transfer, inventions just keep accumulating over centuries. Someone invents the wheel, generations pass, someone else invents an engine, and because of our unique drive to collaborate, our shared intentionality, we eventually combine them into a car. Everything we have is stacked upon the successes of everyone who came before us. So our biology gifted us the remarkable hardware of the Precuneus, and language gave us the ultimate networking software to connect those brains across time and space. Right now, literally, at this very second, your own brain is processing the language in this explainer to absorb concepts that took scientists decades to uncover. As our generational supercomputer keeps growing stronger and more connected, what impossibilities are our connected minds going to conquer tomorrow?